Hello everyone and welcome once again to MJ's Maths and Stats. That's MJ Magic Studio to you. I'm your host, your host, and as usual in the host mode, Mohit Jain. Today we would be taking up a few concepts from coordinate geometry which can be used in solving many questions of algebra also. And these are quite out of the moon concepts which we should know. We would be focusing on slope switch to solve and find lattice point. We will on to the integral solutions for linear and dual quadratic, that is equations of the circles using Pick's theorem, and a small concept of finding out area of any polynomial using shoelace formula. So let's start now. So if I give you 2 points, 2, 0 and 16, 2, 0, 3, and I say that a straight line passes through these 2 points, then what would be the equation of this straight line? So we have got many different ways to find the equation of the straight line passes through 2 given points. First would be like y minus y1 upon x minus x1 equals y2 minus y1 upon x2 minus x1. If these points are x1 y1 and this is x2 y2. Or we may use y equals to mx plus c, where m is the slope. We can calculate m using y2 minus y1 upon x2 minus x1. Or it can be also written as x by a plus y by b equals to 1 if this line passes through a comma 0, 0 comma b. We may use any of these format to find the equation. Let's find the slope. Slope of this straight line would be y2 minus y1 upon x2 minus x1 dy by dx. That would be 2, 0, 3 minus 0 by 16 minus 2 is 14. Let me see if it is divisible by 7. 14, 63. Yes, 29 by 2. Slope is 29 by 2. So now if I put any point y1 equals mx1 plus c, 0 equals 2 into 29 by 2 is 29 plus c. That means c is equals to minus 29. Great. So we have equation y equals 29 by 2x minus 29. So if I multiply this by 2, 2y equals 29x minus 29 into 2 is 58. So the equation of the straight line we are looking out for is 29x minus 2y equals to 58. Now, what is new in this? Nothing. New is the question which can be asked. Question asked is, what are the lattice points between point A and point B? Question asked is, what are the lattice points between point A and point B which are given? Now, by saying lattice points, what do we mean? We mean we are looking out for the points xy between the two given points where both x and y are integers and x and y both lie on the straight line joining our 2 points, which were a 2, 0 and b 16, 203. Those are known as lattice points. Lattice points are integral solutions of x and y, which is given by the equation joining the two lines AB, that is 29x minus 2y equals to 58. एकदम सरल भाषा में, if the equation is 29x minus 2y equals to 58, between these two solutions, because these two are the solutions of this particular equation, between these two solutions on the coordinate axis, on the coordinate graphs, what are the 2 points where both the points value would be integers? And to find the integral solution, we will use the slope switch formula, slope switch concept. Now how we use this? X, y, and we have the first solution, that is 2, 0. If we put x equals to 2, it is 58, y equals to 0. Now, what we need to do? The coefficient with y is 2, but this is minus. What we'll do, we'll keep on increasing the value of x by 2. And coefficient of x is 29. But here is a minus point before this. Since we are increasing the value of x by 2, we will start increasing the value of y by 29. And we will end up getting always the result 58. To make this more simpler, we will take one more example after this, where we will put up both same sign, where we will try to identify how one moves up and moves down. But since here the two signs are different, if x is moving up with a negative coefficient, y will also move up with the coefficient of x. Slope switch. And we can see the integral solution. 2 plus 2 is 4 and 0 plus 29 is 29. We can see 4 into 29 minus 2 into 29 will end up getting 2 into 29, that is 58. 6, 29 plus 2 is 58. Then 6 plus 2 is 8. 58 plus 29, 87. Let me write it here again. 8 plus 2 is 10. 87 plus 29, 3116. 12, 116 plus 3145. 14, 174. 16, 203. We need to stop here because we have come to the solution which is at point B. Because point B is also the solution. Because this line 29x minus 2y equals to 48 passes through A and B. So from A to B, there are 8 points where both are integral solution. And these 8 points lie on this straight line 29x minus 2y is equals to 58. If the question is what are the lattice points between these 2 points, our answer should be 3 plus 3, 6. But if the question is what are the lattice points on this line, including both the points, then our answer is 8. Let's take up one more example to understand this very clearly, the slope switching concept. Let a straight line passes through 0, 20, 25, 0. We are looking out for all the integral solution on this line. First we need the equation of the line. Since this line passes through a, 0, 0, b, equation of the straight line can be written in this form easily. So that would be x by 25 plus y by 20 equals to 1. If I multiply by 100, it will become 4x plus 5y equals to 100. Now we'll start with the first solution, 25, 0. Here you can see the coefficient of both x and y are of same sign, that is plus. Okay, so we'll start decreasing the value of x by 5 and we'll start increasing the value of y by 4 and we will end up getting 100 as the solution always. 25 minus 5 is 20, y is 4. We can put 20 into 4 is 80 plus 5 into 4 is 100. Next, 20 minus 5 is 15, 4 plus 4 is 8, 15 into 4 is 60, 8 into 5 is 40, that is 100. 15 minus 5 is 10, 8 plus 4 is 12, 10 into 4 40, 12 into 5 60, that gives 100. 10 minus 5 is 5, 12 plus 4 is 16, 5 into 4 20, 16 into 5 80 will give us 100 again. 5 minus 5 is 0, 16 plus 4 is 20, bingo, we reached at our next point B. So on this line segment which joins 25, 0 to 0, 20, there are 1, 2, 3, 4, 5, 6 points which will give integral solutions. These are also known as boundary points on the given line segment. We can also call them boundary points or lattice points, boundary points on the line segment AB, including both points A and B, also known as lattice points. Now based on this concept we can frame different kind of equations. Please try this, pause and try this. In how many ways a batsman can score 200 runs with help of only 4s and 6, given that he need to hit both 4 and 6? Please give it a try. So hopefully you must be having the answer by now, and the question was simple. In how many ways a batsman can score 200 runs with help of 4s and 6, where he need to hit both 4s and 6? Let he hit x number of 4s and y numbers of 6. That means 4x plus 6y is equals to 200, or 2x plus 3y is equals to 100 if I divide this by 2. We are looking out for the values of x and y. Perfect. Let's start by putting y equals to 0, then x would be 50. Now using the slope switching concept, I'll keep on decreasing the value of x by 3 and I'll keep on increasing the value of y by 2, and we will see that where we can land up. So next is 47, 2. Let's check. 47 into 2 is 94 and 2 into 3 is 6, bingo. So again 44, 4, keep on decreasing by 3, 41, 6. By 3 would be 38, 8, 35, 10, then 32, 12, 29, 14. Let we have here minus 3 on x and plus 2 on y. Minus 3, 26, 12, 16, 14 plus 2 is 16, 23, 18, 20, and 20, let's x, 20, 40 and 60 is 100, bingo. 17, 22, 14, 24, then 11, 26, minus 3 is 8, 28, minus 3 is 5, 30, 5 into 2 is 10, 30 into 3 is 90, it gives 100, minus 3 is 2, and this is 32. We can't go beyond this because then value of x would be negative. Now it is given that he need to hit both 4s and 6, that means 50, 0 can't be the solution because here he is hitting only 4s and no 6. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. In 16 ways, a batsman can hit a double century using 4s and 6 only, where he is hitting both 4s and 6. And this is nothing but the concept of slip switching lattice points on the given straight line we are looking out for. Let's move on to the next concept. Okay, now on the screen is a simple graph paper, and we are looking out for the area of this particular section, which is bounded by these red lines. This is straight line. If we take each the distance between two dots at 1 centimeter, all these are 1 centimeter, then what would be the area of this particular section? So we can try to dissimulate this particular area into triangles and rectangles, and we can find the area easily. If I join this, area of this particular triangle would be, this is 1, 2, 3, half into 3 into 1, that is 3.5. Then we have this rectangle 1, 2, 3 into 1, that is 3 square centimeter. Then this particular triangle, half into 2 into 1, that will give us 1. And this is 1 is small, rectangle 2 into 1. This is 1 small triangle, 1 small triangle, 1 big triangle. It would be 1 into 1, that is 1. 6, 7. This is 3 by 2. Wrongly I've written is 3.5. It should be 1.5. 3, 4, 5, 6, 7, 8, 8.5. Area of this segment is 8.5 centimeter square. Now, to solve these kind of question, we can use Pick's theorem. Which says that area of any of such bounded figure is given by I plus b by 2 minus 1. A stands for area. I is integral points inside the bounded figure. We can see how many integral points are there. 1, 2, 3, 4, 5. If this is a graph paper, these all are integral solutions. 1, 2, 3, 4, 5. Integral solutions or the integral points inside the bounded figures are 5. B stands for boundary points. How many boundary points, integral boundary points we have? 1, 2, 3, 4, 5, 6, 7, 8 and 9. Plus 9 by 2 minus 1. So this will give 5 plus 4.5 minus 1. That is 8.5 centimeter square. Bingo. So instead of using this tedious solutions, we can use Pick theorem. What we need to understand is, it is A which is equals to I plus b by 2 minus 1. It's been proved, so we are using the proof directly. I are the integral solution inside the bounded figure, integral points on the graph paper when it is plotted. B is the boundary integral points, and minus 1. We can very easily find the area of any of such type of irregular bounded figures very easily. Now where we can use this Pick theorem, we'll see it now. Now we take up a classical example where we can use Pick's theorem and find these kind of solution. AOB is a triangle. OA, OB and AB are 3 line segments as shown in the figure. We need to find the number of points with integral coordinates which lies inside this triangle AOB, excluding these boundary points. Okay. So let us take our first line segment OA, number of integral points or number of boundary points or number of lattice points on this line segment OA, which is 0, 0 to 25, 0 would be 0, 0, 1, 0, 2, 0, 3, 0 till 25, 0. That is 26 points. On the line segment OB, number of lattice points would be from 0, 0 to 0, 20. That means 0, 0, 0, 1, 0, 2 to 0, 20, 21 points. On line segment AB, we are looking out for. First, the equation of the line would be x by 25 plus y by 20 is equals to 1. That is 4x plus 5y is equals to 100. We can use the slope switching format. X 0, then y is 20, y reduced by 4 and x increases by 5. So next would be 5, 16, 20, 80, good. 10, 12, then we will have 15, 16, 8. Next would be 24 and then 25, 0. Bingo. 1, 2, 3, 4, 5, 6. So on line segment AB, we will have 6 lattice points. Now, number of boundary points, that is B, on this bounded figure AOB would be 26 plus 21 plus 6 minus 3. Why I am subtracting 3? Because this 0, 0 is taken twice, one for OB and one for OA. 25, 0 is taken twice, and similarly the 0, 20 is also taken twice, one on OB and one on AB. So it should be 29, 50. So number of boundary points on this triangle are 50. Now, according to Pick's theorem, we know that area of this bounded figure would be given by I plus B by 2 minus 1, and we are looking out for the value of I. Find the number of points with integral coordinate inside this. We are looking out for the I in this Pick's equation. A equals to I plus B by 2 minus 1. Now, area of this triangle AOB would be half into base into height, because it is just a right angle triangle, which would be 250 square units. So we have 250 equals to I plus 50 by 2 minus 1. So I equals 250 minus 25, that is 225, plus 1, that is 226. Bingo. The solution. The number of integral solution inside this bounded figure AOB would be 226 pairs of x comma y in this, inside this, not on the boundaries, where both the points are integers. Now take a switch from the Pick's theorem, which is actually applicable where we are supposed to find the integral solutions, positive integral solutions. Now look at this situation. We have a circle with center 0, 0 and radius 6 units. That means x square plus y square equals to r square, that is 36. We are looking out for all the points inside this circle which have got integral coordinates. Solution. It can be positive, positive, negative, positive, negative, negative, positive, negative. Now, how to find this? For this, we'll use a simple formula which says that if x square plus y square is less than equals to n square, then number of integral solutions for this x square plus y square less than equals to n square is 1 plus 4 times summation of modular n square minus p square, absolute value function, where p equals to 0 to n. We just need to remember this formula. So in our case, we are looking out for x square plus y square is equals to 6 square less than all the solution which fits in x square plus y square less than equals to 36. That's on that note, all the points would be inside the circle. The number of points we are looking out for would be 1 plus 4 into first value of n square is 36. First value of p is 0. That is, let me take this modular function root 36 plus, it is not modular function, it is absolute value function. It is not modular. I'm calling it modular, why I don't know. It is absolute value function. Then p is 1 root 35. Then p is 2. That is 4. 35 minus 4 would 36 minus 4 would be 32 box function. That is nice. 3 9. 36 minus 9 is 27 root plus box function 24 16. 36 minus 16 is 20. Then 36 minus 25 would be 11. 36 minus 36 will be 0. 0. End up. Because value of p would be from 0, 1, 2, 3, 4, 5 till 6. Because n is 6. Now that is 1 plus 4 times. Root 36 is 6. So box function of 6 would be 6 plus root 35 lies between 5 and 6. Box function is 5. Root 32 box function would be 5. Root 27 is greater than 25. Box function is 5. Root 20 is less than 25. That means root 20 value lies between 4 and 5. Box function is 4. Root 11 greater than 3. Box function is 3. We end up here. That is 1 plus 4 into, that would be 15, 25, 28. 28 into 4 is 112 plus 113. Just stick to the formula which we need to understand to solve these kind of questions. There are 113 integral solutions or integral coordinates which lie inside this circle with center 0, 0 and radius 6 units. Okay, on to the last concept in the master class on coordinates. Please also go through the mass point geometry and ladder theorem. The link is there in the description to just complete this segment of master class where we are solving 5 most typical questions from geometry, mensuration, coordinate geometry. How to find the area of a quadrilateral. We know if we have 3 points diagram like a triangle with points x1, y1, x2, y2 and x3, y3. Area of a triangle is given by half mod x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Mod. Why we put mod? Because area need to be positive. So let me join BD, the diagonal. Then we have two triangle ABD. Area of triangle ABD using this formula would be half into, if I start this with 1, 2 and 3. 1 into minus 1 minus 3 is minus 4 plus 3 into 3 minus 6 is minus 3 minus 4 into 6 plus 1 is 7. So that would be half into minus 4 minus 9 minus 28. That is 10, 38 and 3, 41 by 2. Since it is mod, I am taking the positive value. That will give me 20.5 square units. Area of triangle BCD on the same line would be half into, let me start with minus 4 into minus 1 plus 3, that is 2, then plus 3 into minus 3 is minus 6, then minus 5 into 3 plus 1, that is 4, that is half into minus 8 minus 18 minus 20. That is 38, 46. 46 by 2 is 23 square units. So area of quadrilateral ABCD is 20.5 plus 23, that is 43.5 square units. But instead of doing so much tedious work, we can solve and find the area of any n-sided polygon very easily using shoelace formula. Now, how it works? Now, what is this shoelace formula to find area of any polygon, any bounded figure? We know A, B, C, D, if it is a 2 into 2 matrix, the determinant value of this is given by principal diagonal minus secondary diagonal, that is AD minus BC. We understand this, the same concept we would be using there. Please write this values of these points in the order it is given, A, B, C, D, and then A. So point A is, first we will write the x values and then the y value, 1, 6, B minus 4, 3, C minus 5 minus 3, D 3 minus 1, and A is 1, 6. Now, this is how we calculate the value of principal values. So, first principal value, second principal value, third principal value, fourth principal value. Area will be given by half of mod. Add all the principal values first. 1 into 3, 3 plus minus 4 into minus 3 is 12 plus minus 5 into minus 1 is 5 plus 3 into 6 is 18. Now deduct all the secondary values. So these are the secondaries value. It looks like a shoelace going up and down, up and down. That's why they start calling it shoelace formula. 6 into minus 4 is minus 24. 3 into minus 5 is minus 15. Minus 3 into 3 is minus 9. Minus 1 into 1 is minus 1 mod. So let's solve this. This is half into 10, 20, 30, 38, and all will give negative result. Minus into minus would be plus. 9, 10, 25, 24 plus 25 is 49. So that would be 50 and 37. 87 by 2. Bingo, that is 43.5 square units. No tedious calculation, and this can be used to solve and find area of any n-sided polygon. I hope these things would be good for you to solve many different kind of question, many typical question in coordinate geometry, at least for typical questions of mensuration and geometry. Link is there in the description. I'll see you soon. Stay connected and do subscribe. Thank you everyone.